Yeah.
Nice.
Yep, nice. They're nice. All right, well, let's get started here. I'm Paul Fungenbush. I'm Associate Dean in the Hagem School. Nick Valentino up there is kind of our main organizer. So Nick has got to duck out today, but I just want to acknowledge him for helping organize these presentations. And what we're doing today is, what we're doing in this series, the Full Spectrum series, is we're just going through the different programs at U of R and trying to give everyone a little feel for what the field is like, what audio, in this case, what audio and musical engineering is like, and what the U of R program is like. So we are recording this. In addition to people who are joining us live, we do have people who will watch this online. So we are recording, just to let everyone know that. We will have Professor Sarah Smith from audio and music engineering.
I think I have
Uh-oh. Did I lose everyone? No, okay.
No?
Professor Sarah Smith will be presenting first here, give us about a half an hour or so overview of audio musical engineering. We'll have time for everyone to ask questions if you have any questions. We will do a short Hagem quiz and give some swag based on the results of that quiz later on as well. And the Green Center will be popping in briefly just to kind of to introduce themselves as well. So Sarah, you want to take it away?
Sure. So welcome. I am Professor Sarah Smith in the Audio and Music Engineering Department. And this presentation will be basically an overview of what we do as a department, as well as what our major is and different ways you can get involved. So you see on the cover slide, we have this wonderful photo of our new recording studio in Gavitt. And that's sort of been the highlight as far as the facilities in our department, and it attracts a lot of people and a lot of students, but our department really does a whole lot more than that. And so as an outline of what I'm going to go through briefly here, I'm going to talk first about just what is audio and music engineering. I think it's not a department or a program that's at every university. And a lot of our students come in being like, I don't quite know what this is. So I'm going to go over what we define as audio and music engineering, look a little bit at the major itself, what you would do as a audio and music engineering major at the U of R, and then talk finally about other ways to get involved, because our department has a lot of students who get involved through clubs or through a minor or through a cluster and without doing the full major. So I'll touch on that a little bit at the end. So to start, I'd like to start off with what is audio and music engineering. And I think when most people see this phrase or see this term, what they think of is something like this: is somebody sitting in a recording studio at a console, recording music and engineering or producing a record, right? And so that's what we have here. This is Professor Ressner in our department. He's actually teaching a class here, and he is an audio engineer and a recording engineer. But what I like to say is that audio and music engineering isn't just the guy sitting at the console, it's everything else in that room. And so it's not just engineering the record, but in order for that process to happen, a lot of other things had to be designed, had to be built. Somebody had to come and engineer and design a set of good microphones that could be used for different types of instruments. Somebody had to go and design a loudspeaker that was going to reproduce the sounds well so that the recording engineer could hear accurately what was being recorded. Software engineers had to go and write lots of programs and tools in software to enable something like Pro Tools to happen. And then all of the other things like the acoustical paneling on the walls to make the room sound good and sound accurate for recording. The effects pedals that the musicians might be using in a recording session had to be designed, had to be built, their circuits had to be tested. And then lastly, I think audio and music engineering feeds into the commercial space really well. We start to see that everyone's using their voice in all sorts of products, right? Your smartphone probably has some sort of voice activated assistant on it. And so we need good audio signal processing, and we need engineers who are able to design good audio signal processing algorithms for things like here, the Amazon Echo is shown, but more and more devices are just using audio and speech either as an input or an output for everything they do. And the last image I've shown here is the case of hearing aids, because that's another big market and area where audio signal processing comes into play. because we see that computational power is getting more and more accessible and cheaper. And so companies that make hearing aids are able to do more and more things to help people who are struggling with hearing loss and different types of hearing loss. And so all of these things really encompass audio and music engineering. And so in my mind and in our program's mind, we start to divide these into about 5 different areas. And the first area is the recording arts, is the science and art of recording music or designing sound for movies and games and productions. And this is still a core part of our program. We teach courses in these areas. Students go on and do internships in these areas. But we also do a bunch of other things. So the next area is hardware engineering. This would be the design of all these products, microphones, loudspeakers, headphones. And in the bottom right here, I show a picture of some research that's actually ongoing in our department. This is a photo of Professor Mark Bacco next to a set of flat panel loudspeakers, because back about 5-6 years ago, a little bit more, they were looking at the market for speakers and said, wouldn't it be great if that picture on your wall could be a loudspeaker? Or if the front of your television could work as a good quality speaker, so you didn't need to have your big television plus 3 other speakers. Is there a way we can use this flat panel surface to be the audio system, to be the speaker in our system? And they started to design these flat panel loudspeakers that produce really great sound. And so even though some of these designs, like the loudspeakers, have kind of been the same for centuries, there's still ongoing current research in how to make these things better, how to reimagine what a loudspeaker can be. The second area or third area that we focus on is software engineering. So the middle image here is just a setup of Pro Tools, somebody running a whole lot of plugins and different applications within their recording and mixing software. But the other 2 images are actually from student projects in the department. So the top left image was part of a senior design project from last year, where a group made a wavetable synthesizer, which is a form of audio synthesizer that draws out sample sounds from a recorded section of audio and then lets you manipulate them with their pitch and their reverb and their amplitude and distort them in order to create any sort of sound you would like. And the bottom right picture here is also a senior design project that was done with augmented reality. And so they made basically a virtual piano that used this augmented reality headset, and you could put the headset on and you would see this virtual piano in front of you. And when you put your hand out and tap something, it would make the sound of the key that you were tapping. And it was really cool. And so there's a lot that goes into these areas of software engineering and programming for audio. And then the fourth big area, and the area that maybe people start to think about, is acoustics and physical acoustics. And that's an area that I'm personally interested in, and it takes many forms. It can be anything from looking at designing the architecture of spaces. If you were to build a concert hall like the Kodak Hall, what do you need for the acoustics? And down to even more specific considerations, like, is a venue like Kodak Hall that works wonderfully for an orchestra a great place to teach a lecture class? Or is there something different that we need? And we find there is different acoustics that are needed to teach a 1,000-person lecture class and have everyone be able to hear the professor well. And so customizing acoustics of spaces to different needs is a big part of acoustics. And at the bottom here, I just have an example. This is actually a photo from a collection of photos that were released, I believe, by the Berlin Philharmonic. And what it is it's showing the inside of a guitar and all the design and all the structures that go into building a guitar. It's not just an open box inside. There's all these structures, and someone had to decide where to put the bracing and how big these things should be, because they all affect the sound and the acoustics of that instrument. And then the final area is another area that I do a lot of work with, is audio signal processing. And audio signal processing I think of as anything that happens between a microphone and a speaker. So it in a microphone, and then you want to play back an audio signal through your speaker at some point. And sometimes that file has to be encoded to be saved as an MP3. Sometimes you want to do effects processing on it. If it's speech, maybe you want to denoise it to get rid of a bunch of the background noise so that you're mainly hearing the designated speaker. And all of that falls into audio signal processing. For instance, I like to use this example of Amazon Alexa and the Echo because there's so much that goes into it. If you actually were to take one of these things apart, I believe it has 7 different microphones in it. And they do a lot of processing on those microphones in order to know which direction the speaker is coming from. In some cases, identify the speaker and tell what words are being said. And all of that is audio signal processing. How do we get from this string of sound to, I recognize that this is the word Amazon, or this is the word Alexa, and I want to do something in response to that word. And then again, I've included the hearing aids here because more and more modern hearing aids are doing huge amounts of signal processing. They're also doing things like the Echo is, trying to target a specific speaker or a specific voice. So for somebody who wears 2 hearing aids, you can have a common thing that they do is that they do what's called beamforming, so that they emphasize the sound coming from in front of this listener's head and attenuate sounds coming from the surrounding area and the background. And so these are just the 5 main areas within our field. And as you can see, it's pretty broad and it's pretty interdisciplinary. You know, engineers who do this could also be closely affiliated with mechanical engineering or electrical engineering, or a lot of other, or biomedical engineering, potentially even with the hearing aids and how people hear. So it draws on a lot of different areas that are traditionally within other departments and are currently within other departments within the HAGEM school. And so that's an overview of the field in general. And to get specifically into our major is a very similar structure. We think of these 5 main areas, and we include coursework and project work in all 5 areas. So for someone who's an AME major, they start out very similar to all of the other engineering majors. They're going to take end up taking 4 semesters of calculus, 2 semesters of physics. We have an intro to engineering sequence. The main difference is that we do require music theory, and we require some music courses because it becomes important for our students to have a basic grounding in how musicians talk about music. If you're going to record a musician in a studio, you want to be able to converse with that person about their art and about their music. And so we do require typically 2 semesters of music theory for the major. And then our core subject areas are divide into these 5 main areas that I talked about earlier. We offer courses in recording arts, sound design, acoustics, audio electronics, signal processing, and software design. And our engineering major, along with pretty much all of the other engineering majors in the HAGEM school, culminates in a senior design project. And so this is how I envision the large scale structure of our major. I won't go into too much detail about the specific courses. On our website, you can find a curriculum guide that goes into all of the different courses, all of the different things you'll take. But yeah, the first couple years start off with these core areas, and you'll notice that these core areas are common across a lot of engineering. So it's not uncommon for us to have students who come in. Sometimes they start an AME and realize they get interested in a particular aspect and go to another department because they're really interested in the electrical aspects and want to do electrical engineering, or vice versa. They start out doing a different engineering major and then decide they want to do AME. And the first year's curriculum is largely similar. So it's very much possible to do these transitions between majors and into and out of AME. the core subject areas are what I talked about before. The only thing, and these are just a list of our courses, one of the things that I think really distinguishes our program is the presence of these portfolio courses. And what they are is they're 2-credit courses, so they're about half the size of a typical lecture course in terms of the workload and the time, but they're entirely project-based. So for example, I teach the Acoustics portfolio course, and there's no lectures for that class, there's no problem sets, but the entire course is structured around getting students to design and complete their own project. And this semester, we're building a website so that they can all document their project work on a website. And it lets students choose a specific topic in acoustics that's really interesting to them, that maybe wasn't covered in the lecture course, but they're really interested in a specific instrument, acoustics, and they get to do a whole project for this semester about the acoustics of that instrument that they play. And we offer similar courses or require similar courses in audio electronics. Students generally build some sort of guitar pedal for that course, and a course in audio signal processing that's also a portfolio course centered around digital audio effects. And so I think that's a really nice feature of this program, where you have these 3 project classes in addition to the senior design, so that by the time our graduates finish the course, they've done really a lot of project work. And a lot of the courses that aren't specifically designated as portfolio courses also have final projects. The sound design course, the recording courses, the audio software design courses, they all do final projects for those courses as well. So there's a lot of very hands-on and independent project-based learning in the course of the AME major. And then of course we finish with senior design, which is a full year program in our department where students go through and design a product and bring a prototype to completion. So these are just examples of that. There's the bottom left is a synthesizer that was built last year. A bunch of these are from the last few years. The one in the center is actually interesting because these students went on and started a company to sell this. This was a plugin to emulate the sound of cassettes and the audio quality that comes from old cassettes, which is in a lot of ways degraded and distorted, but is also very desirable in a vintage audio community. And so they built a plugin that emulates these types of effects and started to sell it. And I think they've sold a few thousand of them. So they have a pretty steady income stream coming from selling these. And I think they sell them for like 20 bucks a pop, and they've sold a few thousand sort of as a side gig after they graduated. And so that was a really interesting example of a senior design project that turned into an actual product in their case. And so to conclude, I don't want to take up too much time, but to conclude, I did want to say that while we love our audio and music engineering majors, there's plenty of ways to get involved with our program, even if you're not a major. Our classes are generally open to non-majors. I will say that the recording studio classes tend to prioritize the majors and the minors and the people who need it for a degree. We're going to do that simply because the space in the recording studio is limited. We can't take 100 students into an audio recording class because they won't have time to actually record anything in the studios. And so those classes do heavily prioritize the acceptance of AME majors, but the Intro to AME course is open to everyone. The sound design course generally has slots for everyone. And anything else that we teach, we're pretty much not, we want to be open to as many students as possible who are interested. And in that vein, you can do a minor in AME. It tends to be about 18 to 20 credits and essentially involves choosing one of those 5 tracks within the AME major. You start out with the Intro to AME and a music course, and then students will generally specialize in one of those areas, often in the sound design and recording arts area, but also you can do a minor track in audio signal processing, electronics, etc. And then the last option is that we do offer a cluster, which is the Sonics Arts Cluster, For those in engineering, it is a natural sciences cluster, so it's probably a cluster that's most commonly done by students in arts and sciences, because the engineering students are not doing a cluster in a natural sciences area. But that involves any 3 courses within AME and usually includes mostly the recording and sound design courses. So, and then the last thing second to last thing I want to say is that we have student groups, and these are open to anyone. They're not just open to our majors. And they're a great way to meet students who are involved in these things. One of them is the Audio Engineering Society, which is our professional society on a national level. We have a campus chapter of it, and they run events throughout the year. They do general interest meetings when things get back to a state of more in-person activities happening. They do things like pizza nights and soldering nights and study nights and things like that. And the other group that a lot of students from our department have joined is the campus radio station, which is WRUR. They get students involved in all aspects of the radio production. It's not just the DJs and the on-air talent, but they have students working as engineers and doing the recording and the production. And they have their own training system for that. So you don't have to take our courses in order to work for the radio station, but obviously they complement each other well. And the last thing is to attend events. This semester, we're working on getting some virtual events going. In future semesters, we'll have more things again happening in person, but our department will often have guest speakers from industry, and those are open to everybody. We also have a series of open recording sessions. Once the recording studios are back open again, we get local musicians, often from Eastman or around Rochester, to come in and do a recording session. The recording session itself is run by our student engineers, and it's open to an audience. So you can come and just watch a live recording session in progress. It's sort of part concert, part seeing what's happening in the recording studio, and they're usually a good time. And the last category of events are these student events that would be run by something like the Audio Engineering Society. So I know last semester they did a soldering night where you could come to our circuits labs and learn how to solder and solder your own XLR cable and take home this cable that you soldered. So they do a lot of outreach events. And again, those are open to everyone. You don't have to be a major. You don't have to be taking courses in the department. You can just decide that you want to learn how to solder and see that this event is happening and show up. And so I'd encourage those who are interested in learning more about our department and our program to, attend a few events of any sort, or reach out and take a class, do something else. And so I'm going to wrap this up here, and I'm happy to take any questions that are occurring now. For those who are maybe watching this asynchronously, you're welcome to email me. My email is just my name, sarahsmith@rochester.edu. I like to remind students that there's no dot here because there is a Sarah.Smith and it's not me. So my email is just sarahsmith@rochester.edu, and I can answer more questions via email about the program or take some questions now if there are questions from those who are here now. So thank you.
So let me ask you a open-ended question here. I'm fascinated by your program because of the mix of sort of the quantitative, hard sciencey parts, but it also has a really important element of art to it, right? Mm-hmm. I'm terrible in terms of carrying a tune. I don't have any musical talent, but I like music, right? Mm-hmm. Could you comment on the blend of your program and how you bring those two things together?
Yeah. So I think our blend comes from the fact that a lot of our students are the same way. They really like music, and a lot of them play an instrument. A lot of them are involved on campus, but not all of them are, or they just really like listening to music. And so a lot of our courses draw on that. Certainly the recording, the sound design courses are a very artistic course and involve a lot of creative expression. We even find that trickling into work that students have done in other areas. So a lot of times these portfolio projects will be motivated by somebody who's playing an instrument and, you know, really wants to get a certain sound that they can't quite get, and are going, wait, man, I wish I had an effect pedal that would allow me to do this artistic thing that I can't do with what I have right now. And they'll turn that into a project for a course. And again, I think part of what you were getting at is also why we include the music theory component, because I think it's important for our students to remain connected to some of the artistic sense and the aesthetic sense that comes with audio and music engineering, because it provides them an advantage when they go on to jobs and things like that, but it also can provide a gateway into engineering, so that when we go and introduce all these equations and all this math, you know, I teach the intro course, I can say like, oh, this is what's happening when you move the pickup on your electric guitar. And a lot of students come in interested in the music, and that motivates a desire to learn more about the math and the abstract concepts and the engineering.
Thank you. Thank you. Anyone else with questions? Okay, so I have some swag to give away here from AME. They've been very generous. We have some actually really nice sweatshirts and t-shirts with the AME logo on them. We also have some water bottles that we'll be giving away as well. What I'm going to do is I'm going to put up a quick quiz here. So let me share the screen. And I want to have the people who are participating asynchronously, I want them to have a chance as well. So what we'll do, I'm going to stop sharing your screen here, Sarah. And I'm going to put my screen. Let's see. Here we go. If you're watching asynchronously and you would like to participate, here's a screen with 2 questions on it. And what I would ask you to do is email your answers to those 2 questions, A, B, C, to Nick Valentino. Nick's email address is right here up at the top. And this one does have a period in it between the 2 names. But if you email your answers in the next week to Nick Valentino, we will enter you in to win the swag. So we'll base it on, you know, if you get 2 right, then those people go at the top of the list, and we'll pick the first winners from there, and so on down. I will say, if you're not sure of what the answers are, if you do a little bit of quick checking on the Hagem page, you can find the answers to these pretty quick. So anyone who's listening asynchronously, please feel free to participate, and we will get you some swag from AME in the program. Thank you, Sarah. I think Laura has joined us. Laura is from the Green Center, and part of the function of these full spectrum series is to introduce the different programs and give students an idea of what different kinds of engineering involve. The Green Center is also involved in that role. So Sarah, would you like? Laura, would you like to mention a little bit briefly what the Green Center does?
Absolutely. Yeah. So as you're exploring your majors within engineering, it's really all about getting curious and talking to people and trying things out. And the Green Center can help you do all those things. You can come in and speak with one of the career advisors, and you can log onto our website and find out how to do some networking with alumni through the Meliora Collective. The faculty in the AME program have excellent networking contacts from what I understand. So I encourage you to get to know your faculty, and you'll hear about opportunities that way as well. But you could also log on to Handshake, where we post internship and job opportunities too. So that's just a little bit about what the Green Center does. Our website is rochester.edu/career center. So please check us out.
Thank you very much, Laura. Anything else from anyone? If not, and it's always awkward on Zoom, I'd like to say let's give a round of applause for Sarah. So it's just kind of strange. We do appreciate your talking with us today. Yes, Laura, you raised your hand. Oh, this is an applause hand. Okay, I'm sorry.
I'm just clapping.
I get it.
Well, thank you.
Right.
Thank you for having me.
Yep, thank you very much. And we'll close the session for today. Thank you all. Have a good weekend. And again, thank you very much, sir. I really appreciate it.
Yeah, thank you for doing this. I think this is a great thing, you know, for
Yep.
students to kind of find out more about the programs and everything.
I mean, I think the presentation is great, especially for AME, because no one knows what AME is.
Yeah, that's why I start with what is AME. I think people at least have a sense of what mechanical engineering might be,
That's right.
you know, and I like to fill in what we do.
We may have a distorted sense of what mechanical is, but at least we have some
Right.
sense of what
Yeah,
mechanical
that's what I think. I think students come in with a sense, whether or not it's an accurate sense. And, you know, sometimes students come in and go, I don't know what audio and music engineering is.
That's right. Cool. Anyway, thank you very much. Have a nice weekend.
You too.
Bye-bye.